Hey everybody, welcome to, episode 3 or lecture 3 of this stoichiometry 4-part lecture series. Here we're going to talk about mass-to-mass stoichiometry. It's a little different than what we talked about in the last one, which was mole-to-mole and mole-to-mass stoichiometry. In mass-to-mass stoichiometry, we are converting from the mass of one compound or substance in a chemical reaction to the mass of another compound or substance in the chemical reaction. All right, in this case, we are starting out with some kind of given mass amount of one of the substances in the reaction, one of the compounds, one of the elements. All right, and then from there, what we need to do is we need to go in and do 3 different steps. All right. And so this is what is known as a 3-step conversion. And every single mass-to-mass stoichiometry question is the exact same. You're just dealing with different substances and so different numbers. But the steps are the exact same, no matter what you're doing. So what we have is we have our given mass. We then take that given mass and we got to convert the mass to moles, and to go from mass to moles, we multiply by a fraction of 1 mole of whatever your given substance is over the formula mass of that given substance, because the formula mass in grams is the molar mass. All right, so our first step is to go from grams to moles, which is multiplied by 1 mole over the formula mass. Our second step is to change our chemical, and this uses the coefficients in our balanced chemical equation. This is that mole-to-mole step we talked about yesterday. All right, so I take the coefficient of my wanted substance over the coefficient of my given substance. And the final step is to then convert back to grams. And going back to grams, I need a formula mass again, but I use a different formula mass this time. This time, I use a formula mass of whatever my wanted chemical was. And I put that over 1 mole. And that cancels out the moles and gets me back into mass. Keep in mind that with this, the formula or molar masses of the given substance and the formula mass of the wanted substance are going to be different numbers, because the substances are different. So they have different chemical formulas, which means they have different formula or molar masses. So, so let's look to see this in an example. In my example here, I have 12.5 grams of hydrogen gas. This is my starting amount. That's why I've highlighted it in yellow. So I'm going to just start off by writing this given mass as 12.5 grams of H2, because H2 is hydrogen gas. And I'm going to put that over 1 to establish where the numerator and the denominator is. Go back to reading it. This hydrogen gas reacts completely with oxygen gas. How many grams of water? How many is my questioning word. All right, so how many grams of water? I started with hydrogen, H2. I'm ending with water, which is H2O, different chemical. All right, so now I need to follow those 3 steps that are above. The first step is to get my grams of hydrogen into moles. Well, 1 mole is equal to the formula mass of hydrogen in grams. The formula mass of hydrogen, also called molar mass, can be found by finding the mass of the formula. The formula is H2. So I have to take 2 times the atomic mass of hydrogen. Looking on the table, the atomic mass of hydrogen is 1.008. So I take 2 times 1.008. Get a handy dandy calculating device, I get 2.016. If I put that as grams, I have a molar mass, and so my mass at the bottom here is 2.016. My grams happily cancel. Now I have moles of hydrogen. Once I have moles, I can change the chemical. The chemical I am given is hydrogen, H2. So I put 2H2 on the bottom. So I just take it right from the balanced equation. This cancels out my H2s. The thing I want is water. So I take the 2H2Os from the balanced equation. That goes on top because that's what I want. Now I have moles of water. I don't want moles, I want grams. So I have to do one more conversion. 1 mole goes on the bottom so that the mole cancels. And now I need a formula mass in grams of water up on the top. So find the formula mass of water. I need to take the 2 hydrogens and add to it the mass of 1 oxygen. 2 hydrogens I know from earlier. Down here is 2.016. 1 oxygen, I look it up on my periodic table, it's 16.00. Add them together, I get 18.016. If I follow sig figs, I should round to 2 decimals here, so I get 18.02 as my formula mass of water. Plop that in for the formula mass wanted right here. And now I have grams of hydrogen, which is just what I want. So I just have to do the math. I got to plug and chug it in a calculating device. I take the 12.5 times 1 times 2 times 18.02. I get 450.5 grams of H2O on the top. I multiply my bottoms. 1 times 2.016 times 2 times 1. I get 4.032. Now I go in and I divide, and I get 111.7311508 grams of water. Now I got to do my sig figs. 12.5 has 1, 2, 3 sig figs. The 7 tells me to round up. My final answer is 112 grams of water. That is how you do a mass-to-mass conversion. I'm going to keep going and talk about a couple more examples on the next slide. All right, on this slide, I have a balanced equation of sodium carbonate plus calcium nitrate giving us 2 sodium nitrates and a calcium carbonate. I've gone in and done all the formula masses here underneath them, wrote them in white. So let's do the examples. My first example starts with how many grams of NaNO3 are produced alongside 24.5 grams CaCO3. How many grams? This is what I want, highlighting it in orange. How many are produced alongside those 24.5 grams of calcium carbonate? This is what I am given. The number is what I'm given. So let's write that down. That's what I'm starting with. That is my starting amount for this problem. So I got 24.5 grams of CaCO3. I put it over 1. And now first thing I have to do is I have to use that formula mass of CaCO3 in grams, 100.09, all right, to cancel out my grams, and that makes 1 mole, which goes on top. The grams get slashed away, and now I have moles. Once I have moles, I move to the balance equation. What I've been given goes on the bottom. That's the coefficient of my given chemical, which is 1 CaCO3. My wanted chemical is NaNO3. There are 2 of them. I grabbed this whole thing right from the balanced equation. The final step, after I cross out calcium carbonate, is to get back to grams. 1 mole of NaNO3 has a different formula mass. Its formula mass is 85. So that's what goes on top there. And now I go grab a handy dandy calculating device. I have grams of NaNO3 as my only units left. Calculate away. 24.5 times 1 times 2 times 85 is 4,165 grams of NaNO3. Now I multiply all my bottoms together. 1 times 109, 100.09 times 1 times 1 is 100.09. I divide my 4,165 divided by 100.09. I get 41.61254871 grams of NaNO3. 24.5 has 3 sig figs. My answer should have 3 sig figs. The 4, the 1, and the 6 are my 3 sig figs. The 1 tells me not to round, so I get 41.6 grams of NaNO3 as my answer to question 1. And then I'll box it up and move on to question 2. Question 2 starts out with what mass of CaNO3 what mass calcium nitrate? It doesn't say how many, but it still says what? Question word. I want calcium nitrate, and I want a mass, which means grams. I'm given 13.5 grams of sodium carbonate. So here is where I'm starting. My starting mass is 13.5 grams of sodium carbonate. So I go and plug that down as my starting thing over 1. First thing I gotta do is I gotta get rid of these pesky grams. I do that by multiplying by 1 mole over the formula mass. The formula mass of Na2CO3 is right here, 105.99 grams. This causes my grams to cancel, and I am now in moles. Once I'm in moles, I can change the chemical. I want to go from sodium carbonate to calcium nitrate. I grab the coefficient and formulas right from the equation. Both coefficients end up being 1, so I get 1 CaC or CaNO3 2 over 1 Na2CO3. Cross out the chemical. I'm in moles of calcium nitrate. My final step is to get back into grams. 1 mole, we'll go on the bottom and cross out moles. The number of grams of CaNO3 in a mole is 164.10. That's the formula mass. All right, everything set up. I got grams of calcium nitrate left. Plug and chug in the calculator. Multiplying all my top numbers, I get 2,215.35 grams of CaNO3 That was 13.5 times 1 times 1 times 164.10. Multiply all the bottoms, it ends up being 105.99. Now I go and divide 2,215.35 by 105.99, and I get 20.90150014 grams of calcium nitrate. 13.5 has 3 sig figs. The 2, the 0, and the 9 are my 3 sig figs. 0 tells me to not round, so I get 20.9 grams of calcium nitrate, which is exactly what it's asking me to find, mass of calcium nitrate. Box it up, move on to number 3. Number 3, written like number 1. How many grams of sodium nitrate? Well, here's what I want. I want grams sodium nitrate. How many will be produced from 2.75 grams of calcium nitrate? Here's my starting number. So write that down as my starting mass. All right, start with 2.75 grams of calcium nitrate, CaNO3 in parentheses with a little 2. And I plop that over 1 to establish the numerator and the denominator. Step 1, just like the previous 3 examples. All right, 1 mole is going to go on top. Formula mass calcium nitrate goes on the bottom. It's 164.10. Cancels out the grams. Make sure I put the 1 mole on top. Gives me moles. Now that I have moles, I can change the chemical using the balanced equation. On the bottom of this, I put 1 calcium nitrate, because that's what I'm given. I'm given calcium nitrate. The coefficient on calcium nitrate is 1. On the top, I go with what I want. I want sodium nitrate. Coefficient of sodium nitrate is 2. I can now go in and convert my moles to grams. 1 mole goes on the bottom, so it cancels out real nice. Oh, I forgot to cancel out my chemical earlier. Let's go back and do that. The calcium nitrates cancel out. 1 mole of sodium nitrate is 85 grams, so it's 85 grams that goes on the top here. Now I have grams sodium nitrate. I can plug and chug. 2.75 times 1 times 2 times 85 is 467.5 grams of sodium nitrate. If I multiply the denominators, 1 times 164.10 times 1 times 1 is 164.10. I divide my numbers here. 467.5 divided by 164.10, I get 2.8488726 grams of sodium nitrate. Exactly what the question is asking for. I need to worry about sig figs. 2.75 has 3. 284, that's 3 sig figs. The 8 tells me to round the 4 up to a 5. And I end up with 2.85. Need to adjust my screen a little bit. 2.85 grams of sodium nitrate. Right? Every single time, every single mass to mass stoich, 1 mole over the formula mass of your given chemical. Change your chemicals using the coefficients in the balance equation. Formula mass of the wanted chemical over 1 mole. This will get you the right answer each and every time. As always, if you have questions, consult myself if I'm your teacher, or your other teacher if you have randomly come across this on the YouTube. And thank you, and have a good, safe night or day.